Hi everyone, this is Mrs. Snobeck. Today we are going to do Unit 7, Lesson 2, and it's going to be on arc measures and arc lengths and chords, which are all found in circles. So we're going to start out today by defining what is a central angle. So a central angle is an angle with a vertex, in the center of a circle. And its sides are radii. Its sides are radii, which remember that's the plural for radius. So if you take a look here, an example of a central angle is angle ABC. The vertex of the angle, which means like the corner, is right here at B. And then this side is a radius and this side is a radius. So this angle, angle ABC, is called a central angle. Now the sum of the central angles in a circle, can you guess what is angle 1 and angle 2 and angle 3? What are those going to add up to? If you're thinking 360, you are correct. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, in this case, all add up to 360 degrees. And that's true for all circles. If you're at Buck Hill and you do a 360 on your snowboard, you do one full revolution or one circle. So knowing that, will you take a minute, pause the video, try numbers 1 and 2, knowing that the circle central angles add up to 360, see if you can solve for x. So on number 1, I just took 360 minus 165 minus 145, subtracted those both from 360, and I had 50 degrees left. So x was 50. And then on the other one, number 2, I started with 360, I subtracted 85, I subtracted 40, and I subtracted the 90, that red angle there. And after I subtracted all of those, I had 145 degrees left for x. Let's take a minute and talk about arcs. So here you can see we have pictures of minor arcs, major arcs, and semicircles. If you have a minor car crash, maybe you have a little fender bender, maybe you bump into something, but not too much damage. If you have a major car crash, there might be an injury, there might be a big dent in your car, something like that. Minor means small, major means big. So when you have a minor arc, it's a small arc. It's going to connect 2 points on the circle. For instance, right here you can see we have arc AB in red on this first circle right here. Arc AB is a minor arc. So minor arcs are always less than 180 degrees. So minor arcs have a measure that is less than 180 degrees. And we could say something like this. The measure of arc AB, and you put a little curved arc above those, equals the measure of angle ACB. So however big this central angle is, maybe it's 100 degrees, this arc will also have a 100 degree measure. The measure of the arc is congruent to the measure of the central angle. And in this case, they would equal x. Let's talk about a major arc. So a major arc is the longest arc connecting two endpoints on a circle. So you can see on this circle, this arc over here, ADB, goes around the longest distance between A and B. And so if I was going to describe a major arc, major arcs are always going to be greater than 180 degrees. So their measure will be greater than 180 degrees. They will go more than halfway around a circle. And when you name a major arc, you're going to need to use 3 letters, because if I call it arc AB, that means go the shortest distance from A to B. So if I want to go around the bottom of this circle where the red arc is, I would say the measure of arc ADB, and I would put that arc above it. So M means measure, so measure of arc ADB, that is going to be equal to Think about where X is. A whole circle is 360 degrees. So if I just can subtract X from 360, I should wind up with the measure of the major arc. So the smaller arc here would be X, and then the other part would be whatever's left out of 360. All right, next we have a semicircle, and a semicircle is an arc with endpoints that lie on a diameter. This is going to go exactly halfway around a circle. Half of 360 is 180 degrees. So these semicircles are going to have a measure that equals 180 degrees. And you could say something like this: the measure of arc ADB, again, put that arc above it, equals 180. By putting that third letter in there, you know for sure that I'm going around the top side of this and not around the bottom side. So usually for semicircles, you want to use 3 letters as well. Okay, take a minute. Let's look at number 3. It says GJ is the diameter of circle K. There technically should be a little segment bar above that. So segment GJ is the diameter of circle K. Identify each arc as a major arc, a minor arc, or a semicircle, and then find each measure. So take a look at arc GH. Arc GH is right here. Notice this angle, this central angle, is 122. It opens up to that arc. So that is also 122 degrees. Is it major, minor, or semicircle? Well, it's less than 180, so that is a minor arc. Let's look at the next one. Next one we have is arc GLH. So try to find arc GLH on the picture. You start at G, then you have to go through L. So you're going to go down, and then you're going to end at H. So there it is in red. That is arc GLH. Do you think that's a minor arc, a major arc, or a semicircle? It looks like it's more than halfway around the circle, so I would say that is a major arc. And if we want to find out how big it is, we know this part of the circle is 122 degrees, so it's the whole rest of the circle. So if we take 360 minus 122, we should get our answer, which in this case is 238 degrees. Next one, let's talk about arc GLJ. Well, let me erase this here. Let's go ahead and take a look. If we go from G to L to J, to me, that looks like it starts at one end of the diameter and goes around to the other end of the diameter. It goes exactly halfway around. That's going to be a semicircle, and it will be 180 degrees. Okay, will you please pause the video here and try to answer parts A, B, and C for number 4. So starting with arc AED, if we trace that, it would start here at A, go through E, stop at D. Definitely a minor arc. And they want to know, what is the measure of that arc? Well, see how right here we have 63 and right here we have 90? If we add those together, 90 plus 63, we end up with 153 degrees, and that would be the measure of arc AED. It will be the same as the central angle. All right, let's try another one. I'm going to get rid of that. Let's try to do ADB. So arc ADB, we have to start at A. We have to go through D next. So we're going to go this direction and then end at B. So there's many ways to do this one, but what I did is I thought, okay, this part right here is a semicircle. That's 180. And this part right here is 63. So I did 180 plus 63 to get my answer for this one. Turned out to be 243 degrees. Like I said, there are other ways to do that one. I just found that that was a pretty quick way because this cut the circle in half. So I knew this side was 180. I knew this side was 63. All right, last but not least, arc ABD. So we have to start at A. We have to go through B next and end at D. Well, remember how over here we have a 63 and a 90, and that added up to 153? I think the arc we're looking for is everything except the 153. So we're going to take 360 minus the 153 and see what's left. It should end up being 207 degrees. So far we've been talking about arc measures. Now I want to talk about an arc length. So imagine this is a circle where perhaps it's a throwing ring for the shot put or the discus. And what happened is there's been some decay over the years, and on the front of this throwing circle, this circle right up here, there's a toe board. This red thing right here is a toe board where the throwers cannot step over that board. Otherwise their throw wouldn't count. And so they need to replace this toe board because it's decayed a little bit. So if you're going to go into Home Depot and say, oh, I need 100 degrees of that plastic material, please, they're not going to understand what you mean by you need 100 degrees of the material. You need to say something like, I need 8 feet of that plastic material. Well, 8 feet is a length. 100 degrees is a measure. So you need to know how to do arc measures, but you also need to know how to do arc lengths, and there is a formula. The arc length formula goes like this: cursive L. You take the number of degrees of your central angle, so x out of 360, however big that angle is, and then think about your arc length. It's part of a circumference, and circumference is diameter times pi. And so arc length is x over 360, however many degrees out of 360 of your circumference, or diameter times pi. You might also see the formula like this: x over 360 2 pi r, because that is another way of saying circumference. 2 radii are the same as 1 diameter. Let's go ahead and try number 5. On number 5, we want to find the length of arc zy. So here's the arc. I need the number of degrees of that arc, the measure, so that's going to be 75. So to find the length of that arc, I'm going to take 75 degrees out of 360. Now, the radius over here is 4, so the diameter will be 8. So we have 8 pi. When you type this in your calculator, you're likely going to need parentheses around the 75 divided by 360. So go ahead and type that in. If you're doing it correctly, the length of this arc should be 5.24 inches. You might want to check to see if that seems logical. Could this be 5.24 inches? It seems logical to me if the radius is 4. Looks about right. Let's try number 6. We want the length. Again, I see the L word, so I need to use the L formula. The length of arc ZY. So you can see the angle that opens up, the central angle that opens up to that arc is 130. So we're going to go 130 out of 360. And then diameter looks to be 10 pi. When you type it in your calculator, put parentheses around the 130 divided by 360. If you're doing it correctly, the length of this arc should be 11.34 centimeters. Go ahead and type it in and see if you get that. Next theorem. In the same circle or congruent circles, if 2 minor arcs are congruent, then their corresponding chords are congruent. So imagine this arc and this arc are the same length, then this chord and this chord will also be the same length. So if arc FG is congruent to arc JH, then segment FG will be congruent to segment JH. Love that. That's a good geometry sentence. Take a look at number 7. In the figures, circle J is congruent to circle K. So these two circles are the same size, and you can see that their arcs are congruent because they have these little tick marks on them. Little tick marks, which means they're the same length. So if the arcs are the same length, then they want us to find PQ. Well, the chords will also be the same length. So all you have to do is 2x plus 1 equals 3x minus 7, and go ahead and solve this for x. So we'd go minus 2x from both sides, We'd add 7 to both sides, and we end up with x equals 8, but that is not our final answer. They want us to find PQ. So to find PQ, we're going to have to plug in this 8. And so we're going to take the 8, plug it in right there. So 3 times 8 minus 7, which is 24 minus 7, which is 17. So PQ, the distance from P to Q, is 17, and there is no label. We don't have to put the segment bar above this because we're talking about the distance from P to Q. And so distance doesn't have anything above it. All right, next theorem. If a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord and the arc. All right, so what that means, do you see AB right here and you see XY right here? Do you see how they're perpendicular? There's a 90-degree angle there. Well, if that happens, if they're perpendicular, then the radius or diameter cuts that chord in half, bisects it. It also bisects the arc. So let's write this out. If segment AB is perpendicular to segment XY, if they are perpendicular, then it's going to bisect the chord and the arc. So in other words, segment XZ would be congruent to segment YZ, and arc XB would be congruent to arc YB. I'll give you a minute to finish writing that. The converse is also true. So if you saw something like this picture where you can see this distance is the same as this distance, so the chord has been cut in half, then that's going to tell you, oh, they have to be perpendicular. So in other words, segment AB would be perpendicular to segment XY. This is just the converse of the theorem above. Take a look at number 8. In circle S, the measure of arc PQR is 98. Everybody find arc PQR. So it goes from P to Q to R. That arc is 98 degrees, the measure of that arc. It wants you to find the measure of arc PQ. Well, because this radius is perpendicular to this chord, it's going to cut the chord in half. It's also going to cut that arc in half. So if the distance of arc, or the measure of arc PQR is 98, we should just be able to cut that in half and get 49 degrees for the measure of arc PQ. In other words, this side would be 49 and this side would be 49. In circle S, find PR. Might help if I erase some of this. So this time they want us to find the distance from P to R. That means from here to here. It's not an arc this time, so you want to take the shortest distance between P and R. You can see this side is 6. Because this radius is perpendicular, this side will also be 6. So the distance from P to R is just 6 times 2, or 2 times 6, which is 12. And there's no label. Number 10. In circle J, the diameter is 30 inches. So think about diameter. Diameter is all the way across. That means halfway across is 15 inches. So I'm just going to make a little note here, like halfway across is 15. K to M is 22 inches. So from here to here is 22. But if this is perpendicular, JH, it's going to cut that 22 in half. And so what we're really going to have is we're going to have, this is 11 and this is 11. From K to L is 11, from L to M is 11. They want us to find the distance from J to L. So they want us to find this little distance right here. I know this distance is 11, and I do know the radius is 15. Is JK also a radius? It is, isn't it? So that's going to be 15. We want to find that little distance over there. We have a right triangle. We can use the Pythagorean theorem. So I'm going to do x squared plus 11 squared equals 15 squared. 11 squared is 121. 15 squared is 225. So we have x squared equals 104. And then we need to take the square root of that. So square root, and we wind up with x equals, looks like I'm getting about 10.2. And that would be inches. All right, last problem. It says solve for x. Will you please go ahead and pause the video here? Give this one a try on your own, and when you've tried it, then unpause. So the way I did this is I thought about a whole circle being 360 degrees if you go all the way around it. So this part down here is 200. So what I started by doing is 360 minus the 200, and I had 160 left. Now the 160 is going to go from here around to here. But since these chords are the same, that means these two arcs will be the same. They'll be congruent. So if I take the 160 and cut it in half, I get 80. In other words, this side would be 80 degrees. This side would also be 80 degrees. X equals 80 degrees. Well, that wraps up Unit 7, Lesson 2. So will you guys now please try the practice, Unit 7, Practice 2. Let me know if you have questions. Have a good day.